Yeah, thanks everybody for coming out. It was kind of the rain at the end of the world today. I walked over from Penn Station. It was pretty wet. I know, I imagine, because we're at Scandinavia House, some people probably know a bit about Greenland and some people don't. But I thought I'd just start by setting the table, so to speak, and just explaining some facts about Greenland that probably might fill in some gaps as I kind of get into some of the details of the book and some of the stories behind the book. I guess just one caveat before I jump in that I kind of tend to say that a talk about a book isn't the same as the experience of reading the book, of being transported far away to the Arctic. And I hope if you find this interesting, you'll take it out of the library or bookstore or actually go to Greenland, because it's an extraordinary place. I don't think I can capture it through sheer information or photographs tonight. So I'll just jump in. Greenland is the largest island in the world. It covers an area about 3 times the size of Texas, or about 5 times the size of California. You don't want to get it mixed up with Iceland, which is farther away from the United States, actually. And by comparison, actually, Iceland is sort of tropical compared to Greenland. Most of Greenland is above the Arctic Circle. The sun doesn't go down in the summer in most of Greenland, and in the winter times, it's mostly dark all day long. It's also the least densely populated country in the world, if we don't include Antarctica, which isn't technically a country. About 56,000 people live in Greenland. Almost all of them live along the edges on the western coast. There are some small towns and villages on the east coast. The weather on the east coast is much more formidable, cold, and harsh. All told, these villages and towns range in size from about 15 people to the largest city in Greenland, which is Nuuk, N-U-U-K, which is also the capital, and there's 16,000 people in Nuuk. And Nuuk has, if you've ever been there, has one blinking traffic light, although maybe they have more now today. But at least when I was there, it's a very, very small city, or a large village by the standards of the United States. Population-wise in Greenland, about 88% of the residents and the people who live there are Inuit descent, and the rest are mostly Danish and European. One nice thing actually about being an American and visiting there is that you don't actually bump into many Americans, and you're sort of far from the tourist circuit, and it's kind of a nice thing. So there's a scientific community which really descends upon Greenland every spring. And is there really mostly for the most part from May, I would say, until August, when a lot of the science and of all different types, which I'll get into in a moment, happens. We know that the Inuit who live in Greenland came over from northern Canada probably between 800 and 900 years ago. And I think they survived in Greenland and endured, not in spite of the ice, but because of the ice. They created a culture and a way of life that there was no agriculture at all, really, that relied upon hunting and fishing, gathering eggs, to live in really what is probably the world's harshest environment. Since the 1700s, however, Denmark has made the largest impression on Greenland. Missionaries came to Greenland in the early 1700s to convert the natives to Christianity. And in time, after that, they sort of colonized the island, trying to create a sort of hub for economic development, some might say for some exploitation of fisheries and the like. Since the 1970s, Greenland has been moving on a path towards independence with Denmark's agreement, step by step, sort of creating a kind of autonomy. Denmark still supports Greenland to the tune, I think, of about $500 million a year, supporting its economy. But Greenland's economy is built mostly out of tourism, out of fishing, and out of actually mineral exploitation. There's actually believed to be vast quantities of untapped mineral reserves in Greenland. Already, there are reserves identified for copper and gold and rubies. And as the ice sheet starts to recede, as it melts, it's actually exposing parts of land that are being tapped for what we call rare earth metals, with tongue-twisting names like erbium and dysprosium. And these are very valuable, actually, for technology applications. And China, in particular, has been very interested in creating mining interest in Greenland. So why care about Greenland? Why does it matter? Why spend years writing a book about Greenland? All good questions. There's the minerals that I talked about. There's believed to be oil reserves on the northeast and the northwest side of Greenland that are untapped. I personally hope that they're never tapped for reasons of climate. There's a newly navigable Arctic Ocean as the sea ice on the North Pole, but also throughout the Arctic Ocean begins to melt and recede. And Russia in particular has been intent on dominating Arctic shipping routes. And what I think it's turned into is that Greenland has become a kind of potential for vast economic development, but also of important sort of geopolitical or strategic importance in that region. And it makes Greenland valuable enough that even Donald Trump is interested in it. And it's hard to get him interested in anything, it seems, but somehow, some way, Greenland caught his interest. For me, what interested me about Greenland, what I think should interest everyone about Greenland, is its ice. Ice covers about 80% of Greenland. You might think of it as a kind of cupcake where the icing doesn't quite go to the edges. Greenland's ice in the center, it's an altitude of 10,000 feet. The ice is 2 miles thick. And the ice here, if you've ever flown over it on your way to Norway, for instance, or Copenhagen, you see these vast expanse of white. If you ever fly to the center of the ice sheet, which I was very fortunate to do, you find that it's kind of almost beyond comprehension or experience. And this ice sheet is really only one of 2 remaining in the world from the last ice age. The other is the Antarctica, and Greenland's is really a kind of link, I think, to a former world, a world that no longer exists. When the ice age was finally finished about 12,000 years ago, Greenland and its ice endured. It was slightly larger at that point, but it has, for the most part, remained intact. And I think, it's a window to the past and the ice age, and an ice age that hasn't yet ended in Greenland if you go there. But I think if we keep in mind that if all of us went back in time, say 15,000 years, we would stay in this room and we would find it to be very unpleasant, not just because it was very cold, but because we would be trapped under about a mile of ice. The Laurentide ice sheet covered vast parts of North America, and including most of New York City. And that ice sheet began to recede, I think, 15,000 years ago, and it broke and melted and shattered and went into the ocean and raised sea levels in the process. And I think, in a nutshell, that explains why ice sheets are important. If we go back, say, 10 or 12,000 or 14,000 years, there were vast rises in sea level that occurred as all this ice from the ice age slipped into the ocean, as well as ice from Antarctica. And sometimes it would raise sea levels by a foot per century. But what we also know is that there have been things that geologists call, or paleoclimatologists call, meltwater pulses, whereby the oceans really rose somewhere between 6 feet and 10 feet in just a century. That's why ice sheets matter. That's why Greenland's ice sheet matters. That's why Greenland's ice sheet matters, I think, in a warming world. It holds a lot of water that can fall into the ocean, and it could potentially fall into the ocean quicker than we think. And it holds a lot of water because it holds hundreds of thousands of years of snowfalls that never melted, that stayed there and piled up year by year, decade by decade, century by century, and still remain there, and they remain in Antarctica as well. So if all the ice in Greenland melted, it would raise sea levels by about 24 feet. So New York City and most of the world's coastal cities would be drowned. And that doesn't include West Antarctica, where some glaciers there, as we know from field research as well as satellite research, seem to be quite unstable. There's a glacier in the Thwaites, for instance, in West Antarctica, that seems to be in the initial stages of collapse. And unfortunately, Thwaites is about the size of Florida and is going to fall into the ocean. And I think the other thing to remember about ice sheets is that they're lagging indicators, that the climate sort of warms, but ice sheets don't necessarily respond quickly. They take time. They take time to build momentum. They're so large they actually can create weather. But then once they start to react to the forces of a warming world, they start moving, and in the end, some of the responses might be pretty much unstoppable. For about the last 20 years, we know from research and from our records that Greenland's mass of ice is declining. And it loses more mass every year into the ocean through icebergs and through melting on the surface than it gains in the winter from snowfall. And now it loses about 300 billion tons, or close to 300 billion tons of ice per year. And that's about 1 millimeter of sea level rise, so it's really not very much. But unfortunately, here's the really bad thing, which is that we're almost certain that those losses are accelerating, and we know they could get very much larger in the near future as well as the far distant future. So 7 years ago, all this actually caught my attention. In the summer of 2012, Greenland had a huge melting event. I don't know if you read the news this past summer, Greenland also melted quite a bit too. We saw a lot of those photos of dog sleds on these beautiful kind of blue melted icy expanses. It was kind of even actually more intense in 2012. And I thought, as a journalist, well, this is an amazing story. I mean, I knew no human population had ever really lived through and observed the breakup of an ice sheet. Not that it was breaking up, but that it seemed to be in the initial stages of the meltdown. And I could also see that there were terrible downsides here. I mean, there would be floods, there would be property losses, there would be probably a huge and awful impact at some point on the world's poorest that were living near sea level. I understood that the problem is that we really have built a lot of our civilization upon the idea that sea levels stay steady, and that in fact climate and sea levels don't remain stable. We know this by looking back in time through science, and in fact they never have. So for me the questions were, okay, well, how fast will this happen? You know, how fast does an ice sheet collapse? Will it collapse? Can we change our ways? Will we save it? Do we have time to save our cities, or at least most of our coastal properties? And I was drawn in by this idea. And I began to research Greenland to tell a story, to see if there was a story really about the ice sheet, about its past and its present and its future. And in many ways, I guess this began as a climate change book. But as I started to read it deeply, I started to think of it also as a book about scientific discovery, about how we sort of learn to, how we know what we know about ice, about the Arctic, about climate, even about the future, about how we look forward. And as I started to read, I think, all about the history of Greenland as well as the present day situation up there, I also saw that it was a story about people as much as place, that, century after, well, I'd say decade after decade, a lot of these discoveries about the ice were made sometimes by explorers, sometimes by scientists, and we built upon the knowledge of what we knew bit by bit. It seemed to me that there were three questions that I wanted to solve, or that I wanted to answer in the book. And the first is how did we come to understand the ice sheet? Which people did that work? How did we learn what was in it? Because at the beginning, this ice sheet, you couldn't go inside of it. It was an era, pre-technological era. If anybody has ever been there, you would understand it would be completely formidable without technology. You could stand on the periphery or maybe get in a few miles, but between the weather and the crevasses and the mountains, it's almost impossible to get farther than that without a kind of proper planning. So, who are these people who are the first to sort of map it and understand it geographically? The second question was, what secrets did the ice sheet contain, or the ice? What some people found was that you could dig down into the ice sheet, and because it's built up of thousands, really hundreds of thousands of years of snowfall, it contained records, actually. It was kind of an atlas of time. It contained records of ancient volcanic explosions like Krakatoa, or some evidence of ancient lead smelters in ancient Rome. And all this was locked inside of it, if you could just figure out how to kind of find the key. Third question was, how will this ice sheet fall apart? We've never seen anything like that happen before. Is there a way to map it? Is there a way to predict it? Is there a way to predict who will save it? And which were the people who were working on those questions? So I went forward from that point, and as you can see, I wasn't going to tell the story of the native Inuit, which is a fascinating story, and there are a lot of good books about the Inuit Greenland and the culture there. In many ways because the Inuit were far less interested in the ice sheet than some of the Europeans who wanted to explore it. The Inuit were focused on the coasts, on hunting and fishing. The ice sheet itself held no sustenance, there were no hunting grounds, there was no nourishment, and it was incredibly dangerous to venture on it. So for me, the question really became, who are the people who really, how to begin a book? And the Inuit, as I said, came here 800 to 900 years ago. There was another group that came there in about 985, and these were known as the Greenland Norse. This was a group of people, eventually numbering about 2,500, that came from Iceland to Greenland, and they created a couple settlements on that southwestern coast of Greenland that were known as the Eastern and Western settlements. They were led by a man named Eric the Red, whose son was the Erikson. The Greenland Norse stayed from 985 to 1425. As I said, we now believe there were probably about 2,500 people all in all in these settlements. It was a very difficult place to live. As I said, agriculture was almost impossible or very difficult. And the Greenland Norse died out. They're one of history's supreme mysteries. We don't really know why they disappeared. There are different theories, but historically they are literally a dead end. So for me, that neither the Inuit nor the Greenland Norse solved the question of how to begin. And eventually I began to decide that really the book had to begin with this guy, with Fridtjof Nansen, who was a Norwegian scientist and explorer, later a humanitarian. He won actually the Nobel Prize for helping World War II refugees. And early in the 1880s, Nansen, who was a science student for his PhD, was working on a sealing ship that was literally killing seals and harvesting them for their pelts and fat. And he was doing science experiments on the ocean. He was on the ship that was on the eastern coast of Greenland, that kind of bad weather area of Greenland. And he looked over to Greenland. He knew it had never been crossed, that ice sheet. He could see the ice sheet. And he decided that he was going to do this. He didn't do it then. He actually planned an expedition, came back to Norway, found some friends, recruited some other people, and decided in 1888 that he would get dropped off on that east coast of Greenland, and he and his troop would cross the ice sheet. They would be the first people ever to cross the ice sheet. And not only would they cross it, they would pull sleds up the hill on the eastern slope of the ice sheet, and then they would ski across the top and ski down it on the other side. Nansen called this the scheme of a lunatic, and you can see from his picture that maybe that was kind of right. He actually had a good sense of humor about himself, and he was a wonderful writer and had a kind of fairly gentle side. But the actual idea for crossing the ice sheet he knew would be absolutely physically intense and exhausting. There were different theories about what was in the middle of the ice sheet at the time. Some people thought that there was an oasis, that it was kind of a place where there were green trees and frolicking reindeer in the center of the ice sheet. But again, there was, in this pre-technological era, there was no airborne observation of what was in the middle of the ice sheet, so it was something of a mystery. I'm going to just read a quick passage from the book, if that's okay. And I think it kind of captures what it was like for Nansen and his group. Again, I think I have a photo here. You can see them on the bottom left. I want to stress that this was absolute utter misery. I mean, these sledges that they're pulling up that eastern edge of the ice sheet was just brutal. And I think this kind of captures it a little bit. There were 6 men dragging 5 heavy sledges. Each of these sledges laden with at least 200 pounds of gear: tents, sleeping bags, raincoats, skis, snowshoes, cameras, thermometers, barometers, canned food, dried food, tea, sugar, coffee, chocolate, matches, stoves, and fuel. All the sledges were pulled during the night when the August sun wasn't melting the snow atop the ice sheet, transforming it into a soft white bog that made hauling even more difficult. The skis were packed up for later. They would be useless at this steep gradient anyway. Using boots fitted with sharp metal crampons, the men needed to hike up through the crevasses to make their way to what they anticipated would be the smooth rising dome of the central ice sheet. The ropes for the sledges burn into their shoulders. The white glare, even at nighttime when the sun barely slips below the horizon, leaves them nearly snowblind. The frozen hills and valleys seem to ripple on without end. One of Nansen's team will later note that the terrain in these early days makes him feel hopeless, as if he is walking upon the waves of an interminable ocean of ice. On August 17th, a storm of wind and driving rain confined the men to their tent for 3 days. They passed some of the time reading the Bible and books about glaciers, but mostly they lay on their backs, gazing at the tent roof and listening to the rain splashing overhead and wind tearing and shrieking around the walls. When the rain stopped, Nansen and his men pushed on. According to his journals, they could usually cover 3 or 4 miles per day. By August 23rd, a week after they began, they had made it beyond the worst of the crevasses. By August 26th, they had reached an altitude of around 6,000 feet. On good days, it seemed that they moved at a pace of about 10 miles. On bad days, days when pulling the sleds through the soft snow cover felt like pulling them through sand, they covered about half that distance. When they finally reached the smooth rising dome of the ice sheet, they found it easier but still physically punishing. Apart from the treachery of the soft snow that was clinging to the runners and the sledges, the men experienced a constant and unquenchable thirst. In planning the expedition, Nansen had reasoned that each man should fill a flask with snow in the morning and let their body heat melt it to water. But 1 flask of water wasn't nearly enough to slake their dehydration. At the same time, fuel for the stove was too valuable, and their time was too precious to stop and cook it down for drinking water. So they would have to wait for the end of each day, and even then it wasn't enough. Surrounded by trillions of tons of frozen water, they awoke thirsty, worked thirsty, and slept thirsty. By the end of August, with hundreds of miles of ice still in front of them, the men on Nansen's team began to question whether their goal was worth such misery. They all survived. As you can see from the map, they actually chose a route that was a little south of what Nansen had originally planned. It was a shorter route to the west coast, and they made it to Nuuk, what we call Nuuk today, which was Scandinavia at the time, and they survived. They found that there was no oasis in the middle of the ice sheet. It was just all ice everywhere. And Nansen, as a scientist, and his team made some meteorological readings and collected some scientific information. And when word got out that they had crossed the ice sheet and had lived through it, they became kind of heroes in Scandinavia, in Norway especially, and in Denmark. And I think this is really the beginning of the modern era for studying the Greenland ice sheet. I mean, he did it as a kind of heroic exploration, but he was a scientist as well. And it brought to mind that other people could do this too. Fortunately for me as a writer, Nansen, like all good heroes, had like this deadly and evil rival. And this was Robert Peary, who was an American. And Peary actually had the dream of being the first person to cross the Greenland ice sheet. If you know Peary's name a little bit, his big dream was to reach the North Pole first, which is debatable whether he did, probably didn't, but he claimed to. But earlier in his career, he wanted to be the first person across Greenland. And when he found out, when somebody told him that Nansen had been the first person to cross it, his wife said it looked like somebody had just told him that someone had died. Nansen had stole his dream away. Peary, anyway, decides that he's going to cross the Greenland ice sheet, and he's going to do it, bigger and better, and in a more daring way than Nansen ever had. He's going to actually go to the north of Greenland. You can see on the right a very old map of Greenland, and he's going to do, rather than a 300-mile trek across the ice sheet, he's going to do about 600 miles across and back in the north of Greenland. You read some of these expeditions, read about him in either his first-person memoir or some of the journals he kept, or those that other people had written afterwards. These are some of the most miserable journeys I think I've ever come across. And at the end they're eating shoe leather and frozen chunks of walrus meat, and then they're eating the dogs that are driving their sleds, and it's just horrible, beyond horrible. But I think what Peary and Nansen do is that they actually correspond. Nansen writes Peary a congratulatory letter, and Peary accepts that with dignity. And they really, I think, don't solve some of the bigger mysteries of the ice sheet, but they begin to show us its contours. They begin to show us that it's a place that's navigable, a place that you can visit in a way that you can go onto the ice sheet and still survive. And I think also they begin to bring other people and arouse interest in this sort of frozen island. And I think quite crucially, they begin to inspire a next generation. And one of the people actually who later becomes good friends with Nansen and friends with, not friends with Peary, but a correspondent with Peary, was Knud Rasmussen. And Knud Rasmussen was a great hero in Denmark. He's actually part Inuit. And Rasmussen was a generation younger than Nansen. And he lived in Greenland as a young man, then moved to Copenhagen, but decided he wanted to become sort of Greenlander again and return there for many, many expeditions afterwards. And he's really, I think, the man who bridged the heroic age of exploration with the later age that came afterwards. He sets up a trading station in the north of Greenland, northwestern Greenland, that he calls Thule, and starts trading with the local Greenlanders, trading them. They would trade him fox pelts that he would sell in Europe, and he in return would sell them guns or trade them guns and knives and food, which had a very kind of stabilizing effect on the populations there that had until then really been affected by bad years with terrible starvation and difficulties. And he becomes a kind of hero to the Greenlanders as well. He's also known as one of the greatest dog sled drivers that ever lived, which in New York is not such a big deal, but in Greenland it's something close to being a rock star. So I think we can think of Rasmussen again as the last of the great Greenland explorers. And in addition to all these sort of trips he took around Greenland and also through Canada, he charts Greenland exhaustively, maps its coasts and geography along with some other colleagues at the time. And he's an anthropologist as well, and he collects the stories of the Inuit and works to try and understand why Inuit tribes in disparate locations of Greenland can understand each other, and also why they share a kind of common root language with the Eskimo of Canada as well. Crucially, I think that, well, maybe I'll put it this way, that I think history is very messy, especially when you're working to research these stories and these people. And I think we tend to think that there's this age of exploration, and that what came after was maybe an age of science where we now are. And I think what happens is that you see a kind of transition where Rasmussen was an explorer, but also keenly aware of bringing scientists. He was an anthropologist, a social scientist, but also bringing botanists and other geologists to Greenland to explore and understand the place. Really, I think the most transitional figure came after Rasmussen, and this is Alfred Wegener, who was a German scientist. Wegener was more of a scientist than explorer, but early in his career, he crossed Greenland in 1912, a miserable crossing with ponies with a couple other men. And later in his life, when he was, I think he was actually 49 years old, in 1930, he decided to launch a very large scientific investigation of the Greenland ice sheet. You might know Wegener's name because he's credited with the theory of continental drift. But really a lot of his thinking and a lot of his life was spent thinking about Greenland, thinking about ice ages, thinking about the meteorology of Greenland, which was of particular interest to him because it was understood that the ice sheet sort of created its own weather, and you might be able to predict weather patterns in Europe if you could understand some of the weather in Greenland before it moved over to Europe. In 1930, Wegener set up, or sponsored, I should say, 3 stations in Greenland to investigate the ice sheet. There was one on the western coast, there was one on the eastern coast, and they set up one in the center of the ice sheet known as Icemitte, or Mid-Ice Station. And in many ways, the center of the ice sheet was really the crucial scientific post. It was where several scientists were going to winter over. They were going to stay there all winter, study the meteorology of Greenland, as well as dig maybe down into the ice to try and understand the ice sheet better. In the Arctic, it seems like everything goes wrong and everything's always worse than you think it will be, and that was the case with the Wegener expedition. I won't, if you're ever going to read the book, I won't spoil what happened, except to say it's rather tragic. But there was a great scientific sort of yield that came out of this expedition, and it came out of that science station in the center of the ice. There were 3 men trapped there for the winter without any communications equipment, with just enough fuel to get by and just enough food. And they dug into the ice and lived under the ice sheet, about 6 feet under. They built a kind of cave that they dug out of the ice to protect them really from the elements. And one member of that group was named Ernst Sorge. And Sorge's job was to understand the ice sheet. There was another guy with them who was trying to understand, take weather readings and setting up weather balloons. But Sorge decided to dig down into the ice sheet during that winter when really there was nothing else to do. And they couldn't be saved, they couldn't make it to either coast. They were really just marooned there until a rescue party could come in the spring. So with a shovel, he dug a staircase into the ice. And he dug down. Eventually he dug down just over 50 feet. He created this really dark pit of a steep descending staircase. And there are actually photographs of him with like a headlamp in this pitch black space. And what he would do is he would carve out blocks of ice. They're kind of not quite ice, it's called firn. As the snow is getting pushed down by successive snowfalls, at first it turns into a kind of proto-ice, a sort of firn that's very stiff and almost like styrofoam or hard styrofoam. And he would bring these blocks, excuse me, back up to the cave where they were living, and he would measure them. He would measure their volume, and then he would measure their weight on a scale, and he would figure out their density. And what he figured out actually was that in going down 22 feet, the snow, or the firn, as they call it, gets denser as you go down. And that wasn't really a surprise to him, but he also detected that there was a kind of pattern between summer ice and winter ice. And they differed in density in a very regular way. And you could actually figure out how many years you were going down if you could just figure out the density pattern. And what he understood too was that by getting to the bottom of that hole, that staircase, he had actually gone back in time, 22, I think it was 22 years. And there was that snow, it was kind of there for posterity. And so when I talked about that second mystery, what secrets did the ice sheet contain, I think in many ways Sorge's work starts that modern study of what we now call ice cores, of digging into the ice sheet, or really drilling into the ice sheet as we started to do, as scientists began to pull up these sort of cylinders of ice that we could study to sort of see the past in many ways. To find that the ice sheet really has a record of weather, of climate, ancient climate, and of events like volcanic eruptions, for instance, storms that buffeted the ice sheet, and all sorts of other things as well. This was 1931 that Sorge dug his staircase in the ice, and nothing actually happened right after. You would think it did open the door to more research, but really in 1930, in the 1930s, Europe it was a time of war, or at least the build-up to war, and no real research happened on the ice sheet. And really during World War II, Greenland became a kind of strategic location for the Allies that wanted to set up air bases there for refueling planes, but also for, again, meteorologists who wanted to detect weather patterns. And in fact, some of the meteorological readings from Greenland formed the basis for the invasion of D-Day, trying to predict what kind of weather would be appropriate for Normandy. But it really wasn't until just after the war that scientists began to look again at the Greenland ice sheet. There was one person in particular, a Frenchman named Paul-Émile Victor, who was fascinated by the Wegener expedition and launched a kind of, I'll just go into like this sort of chronology here, and launched a kind of 2-year scientific investigation of the Greenland ice sheet. And Victor brought a team of Frenchmen to the center of the ice sheet. He actually didn't stay over for the winter, and they created a science outpost very near to where the German mid-ice station had been 2 decades before to study the ice sheet. And the French scientists drank a lot of wine and smoked a lot of cigarettes and lived fairly well under the ice in a hut, and much better than the Germans had a couple decades before. And they did some wonderful science as well. They started to drill down into the ice as a kind of proof of concept that this could be done. They also did things where they set off explosions with TNT all around the ice sheet to try and gauge seismic waves from the explosions, which would give an indication of how deep the ice was. You could measure the wave as it bounced off the bedrock deep below. But I think what really advanced the science of Greenland after World War II was that the US government began to think that it needed to set up a permanent presence in Greenland. And I don't mean this in a heroic way, but the Americans, when they do things big. And they arrived actually at the same place where that guy Knud Rasmussen had set up a trading station many, many years before. And in fact, Knud Rasmussen had once suggested to an Air Force colonel, this would be an ideal place to set up an air base because it has a great landing strip or great flat area for a landing strip and a cold water port. And the Americans arrived there in northwestern Greenland at what became known as Thule Air Force Base. And really virtually overnight, they built one of the largest Air Force bases in the world that at one point housed 10,000 people at a time. And the reason for all this was that the Cold War paranoia was ramping up. And it was believed that the most direct way from Moscow to Washington was over the Arctic and over Greenland, and that Greenland was particularly important, that the next war would be fought in the Arctic. So that we needed Arctic defenses, we needed Arctic surveillance. At least that was the idea. Now, what was actually important is that the Army and the Air Force also thought that we needed more Arctic science. And there was a group of engineers and scientists within the Army Corps of Engineers that began to do a lot of research on the Arctic and on snow and ice. I mean, the belief was that if we were going to wage a war in the Arctic, we needed to understand sort of prosaic things, like how do you land a plane on ice and snow? Or how do you build buildings literally on ice? Because actually you can't really build a building on ice and snow. The heat from the building will sink it down. So there's special ways you have to do all of these things that are actually more complicated than it seemed. But there were actually some scientists who wanted to kind of piggyback on all the money that was being spent by the Americans and do real science. And one of these was a Swiss-American glaciologist named Henry Bader. And he knew that the Army would spend basically any amount of money on anything. And one thing that the Army was doing at the time was something rather crazy. They were building an under-ice base called Camp Century that was about 130 miles in from the edge of the ice sheet. They had dug these huge trenches and covered them over and put buildings underneath. And the idea was that they would put about 200 to 250 men in this camp, and that they would sort of prove and understand whether living under the ice sheet or creating a military installation under the ice sheet was a viable idea. There was also a kind of ulterior secret motive. They wanted to also understand whether it was viable to keep nuclear warheads under the ice sheet, with an idea of what was called Project Iceworm, that maybe you could have nuclear warheads and move them around by rail. So some of the people actually working at Camp Century were doing tests on weighting things on sort of small railways to see if this was just crazy or absolutely crazy. What was also happening was the snow was piling on top of Camp Century, and it was slowly getting crushed as well. But before that happened, Henry Bader, the glaciologist, wanted to dig an ice core, drill an ice core really. And when you're actually under the ice, you just drill through the floor. So these guys, the engineers at Camp Century, set up a drilling rig, and they went about drilling from the surface of Greenland. Actually, they were a little bit under the surface of Greenland, down to the bedrock. They weren't in the center of the ice sheet. In the center of the ice sheet, the ice is about 2 miles thick. Where Camp Century was, they thought it was about 1 mile thick. And they began in 1963, if I remember correctly, and they actually hit bedrock on July 4th, 1966. And when you're drilling down and pulling up these cylinders of ice, you don't pull it up in one big increment, you pull it up in these segments. Actually, nowadays, there's a very kind of systematic way of doing it where you have 1 meter segments of ice coring. But at the time, they really, piece after piece would come up from this drilling rig. And it took quite a long time. This was absolutely new science. Nobody really knew how to do it and how to retrieve an ice core. There were different ideas at the time. Nobody had ever kind of built a drilling rig just for drilling out of ice. And the idea really was that they would analyze these ice cores. And fortunately did was they hooked up, the American scientists hooked up with a Danish scientist named Billy Dansgaard, who's in Copenhagen, and took samples of this ice. And Dansgaard believed that, well, not Dansgaard believed, Dansgaard had come up with a way to analyze ice. He was using what we call an isotopic analysis of stable isotopes. He was looking at oxygen atoms within the ice, and he found a way to actually find ancient temperatures that if you could match the approximate year of the ice with the stable isotope profile, you could actually figure out what the temperature was far, far, far in the past. The scientists working on these ice cores in 1969 with Dansgaard actually published a paper in Science magazine called 1,000 Centuries of Climate from the Greenland Ice Core, which was a revolutionary article at the time. People knew that ice cores had some information in them, but nobody had ever thought that you could actually figure out what temperatures were from long, long ago. And that's not a trivial bit of information. You could find out why certain migrations happened. You could match temperature profiles with other things. It was also understood that if you could capture the bubbles in ancient ice, you could actually figure out what the atmosphere was like thousands or tens of thousands of years ago. And in fact, eventually in Antarctica, they did capture that. And they compared the temperatures at a certain time of year, certain years with the ancient atmosphere profile, and you could chart the rise of CO2 with the rising temperatures and create sort of charts that actually showed a very, very almost perfect correlation between the two. What these cores also found, and in subsequent years there were other coring experiments that happened all over Greenland and Antarctica, because Camp Century was really the first one, was that the ice actually, just see the next one, yeah. For instance, in the late 1980s and early 1990s, there was a coring project in the middle of Greenland that actually was 2 miles down called GISP-2, which stood for Greenland Ice Sheet Project 2. It's a beautiful photo by a woman named Peggy Weil, who's an artist, who photographed those ice cores. And those are, I think, 1 meter long segments, and you can see some of the sort of traces of volcanic residue and other dust, as well as some of the stripes in the ice. But I think I'm getting ahead of myself. One of the things that both the ice cores from this experiment as well as Camp Century showed was that climate doesn't always sort of move in a sort of smooth way. For instance, as temperatures get warmer, climate can almost switch drastically from different modes. This has kind of become known as abrupt climate change. One of the ice cores from GISP-2, for instance, showed that about 11,700 years ago, the climate, the temperatures really went up about 18 degrees Fahrenheit in the course of about 10 years. And I went to go see that core. Actually, all these cores are still existent. They're kept in either Colorado or Copenhagen. And you can go, if you're a journalist or a scientist, you can go see them and do experiments on them if that's something you're interested in doing. And fortunately for me, the scientist I was with brought out that essential core that showed this drastic change in temperature. And it was a woman named Joan Fitzgerald, and she pointed to one side of the ice core and said, this is the Ice Age. And this is about 10 years later, and this is not Ice Age. Which, in between that very brief period, showed us that temperatures, I think, can change drastically, quickly, and that really climate is much more unpredictable than we think. So I think this takes us maybe to that third great question of the ice sheet. You know, if the first was, what is it and how do we explore it? And the second, at least to me, was about unlocking its historical secrets. The third was, you know, will it collapse? Or will some of the glaciers collapse? And how will they collapse? And that's a bit of a different question. It took me down different roads. It involves a lot of science about climate models. It involves a lot of satellite observations that take a look at sort of how Greenland's ice is receding and how Antarctica's ice is changing as well. At the moment, as I said, Greenland loses close to 300 billion tons of ice per year. And about half of that comes off the edges, off glaciers like this one. This is a glacier, Helheim, on the east coast of Greenland. These are vast rivers of ice that go to the coasts, and at the end, massive chunks of ice break off and float away as icebergs, and then they melt to the water. It's a great photo by Lucas Jackson. The other way that Greenland loses ice is by surface melting. That these lakes and rivers, these wonderful, beautiful pictures that you see of Greenland melting in the summer that are just staggeringly beautiful, but also indicate in a warmer world, Greenland will shed massive amounts of water. And these lakes and rivers kind of run off the edges or run down through holes called lands and exit off the Greenland ice sheet. And again, raise sea levels in the process. As the Earth becomes warmer, as Greenland in particular, and the Arctic sort of start warming at about twice the rate of the rest of the world, it really has put the ice's future in jeopardy. Part of the reason is that there are these feedback loops that happen in Greenland. For instance, with surface melting, as Greenland melts more, the ice sheet gets lower in elevation. And at lower elevations, the temperatures are warmer, so it melts even more. And it's a kind of self-reinforcing process. The ice sheet is also getting darker because of soot, and also because there's algae growing, especially on vast expanses of the western ice sheet. And that darkens the ice sheet and makes it absorb more solar radiation, which melts it more, and then it gets even darker and melts even more. So these kinds of, I guess, like I said, these self-reinforcing processes are fairly worrisome in the sense that they raise the question of whether Greenland's ice sheet can survive over the long haul. It seems clear to me from talking with scientists and sort of that the decisions we make probably over the next 20 years will affect the fate of the ice sheet. And by extension, I think the fate of our coastal cities. Because the more Greenland melts, the more it will melt. There's a question of whether we hit a kind of point of no return or tipping point whereby Greenland becomes, these feedback loops kick in to such an extent that at least over a very long period of time, Greenland will not survive, or at least the ice will not survive. And if we keep going at the rate we're going, I think, with fossil fuels, with CO2 levels in the atmosphere and emissions and temperatures rising, I think probably it's clear that a good portion of the ice sheet, maybe even most of the ice sheet, will be gone in a few hundred years. And with that, I think most of the great cities in the world would be. I think we have to remember that 24 feet of sea level rise isn't a problem. Hundreds of millions of people around the world live within a few feet of sea level. And really just a couple feet of sea level rise in a terrible storm can flood an area, and we already see cities starting to become unlivable with just a minor amount of melting. So it's really not, we don't need a catastrophe of a total ice sheet collapse to make a lot of the world unlivable, unfortunately. But on a brighter note, I would say that what some of the ice sheet models also show is that if we change the path we're on, a lot of this ice can be saved. And that goes for Greenland as well as some of these glaciers in West Antarctica too. I just want to close by reading a quick passage of the book on meltwater, about what it's like, maybe what it's like for me, or what it was like for me going up to Greenland and sort of spending time with scientists, and sort of captures the scene there. In the book, I call Greenland the world's largest laboratory, and it sort of felt like that a lot of times, because when you're there, it's amazing how many people are doing really interesting things, but also how urgent the situation feels. Many of the scientists coming to Greenland were there to gather observations about the ice and make computer models more accurate, so that the future could be projected with greater confidence. Some were passing through airports on their way toward any one of the hundreds of glaciers along the island's coasts. Others were leading international teams, drilling deep ice cores out of the center of the ice, both to better understand the ice sheet's flowing movements and to fine-tune their historical knowledge of Greenland's climate. On a sunny morning at Kangerlussuaq Rock Airport, you could sometimes see J.P. Stephenson smoking a pipe and driving a front-end loader, he's a scientist, bringing coolers of ancient ice cores to a plane heading back to Copenhagen. But there were so many others, too, arriving for meltwater season. Scientists mustering supplies to camp on the ice sheet and measure water pooling along its surface, for instance, or to gauge streams rushing into moulins, the deep holes in the ice sheet that bring water into secret plumbing channels thousands of feet below. In the local cafes, you could meet glaciologists, hydrologists, anthropologists, geomorphologists, and sedimentologists. Greenland seemed to me like Los Alamos in the 1940s, The small city in New Mexico that served briefly during World War II was the nexus for all subatomic knowledge. Except here it was all about the science and impacts of lost ice. You might chat with marine biologists studying the survival habits of narwhals and polar bears in a changing habitat, or you might discuss ancient history with archaeologists who happen to be digging into the remains of the Norse ruins in the Southwest. The latter were racing to finish their work before the permafrost that preserved those remains melted and the artifacts deteriorated. If and when that happened, the historical clues to the Norse disappearance in the 1400s might vanish forever. All of these research projects conducted between 2014 and 2018 happened to coincide with the hottest years ever recorded on Earth. But in Greenland, the rise in temperatures was even more acute than rising global averages implied. Much as climate models had predicted, the Arctic regions appeared to be warming at twice the rate of the rest of the world. In June 2016, a visitor could relax outside in a t-shirt and shorts in Nuuk, Greenland's capital city, previously known as Gotland, where it was warmer at 75 degrees Fahrenheit than in New York City. The winters in Greenland were becoming more temperate too. At the National Oceanic and Atmospheric Administration, scientists summed up their annual observations for 2017 by noting that the Arctic environmental system has reached a new normal. The region now appeared to be in a permanent state of decline, with thinner snow cover, steady reductions in the mass of ice in the Greenland ice sheet, and dramatic losses in sea ice in the Arctic Ocean. In fact, over the past 3 decades, the sea ice cover had been reduced in area by about half, and less ice in turn meant that darker and more open ocean waters could absorb more sunlight. That change would melt the ice even more, and thus bring even more heat into the region. It was a painful feedback loop, and it seemed that no place in the north would be immune to the seeping warmth. In February 2018, at Cape Morris Jesup, a weather station at the northern tip of Greenland, instruments registered daily temperatures 45 degrees Fahrenheit above normal. Seeing as the station was only 400 miles from the North Pole and was shrouded in the constant dark of Arctic winter, the news left many of the world's meteorologists dumbstruck. The Arctic is the world's cooling system, a Finnish official, Stefan Lindström, remarked not long after. If we lose the Arctic, we lose the world.